Question number 21. Use Laplace transforms to solve the given system of ODEs. So here we have a Laplace, or we have a system. It's a linear system. First order. ODEs, we're going to apply the same basic rules that we used in solving a Laplace and a differential equation using Laplace transforms. We'll take the Laplace transform of each equation. That'll convert this system of differential equations into an algebraic system. And then once we have the algebraic system, we'll solve for x and y. So I'm going to start by applying the Laplace transform to each term. And there, the Laplace transform of 2 times dx over dt. That's going to give me sx minus x of 0 plus dy over dt. The Laplace transform will be s times y minus y of 0. And then minus 2x equals the Laplace transform of 1 is 1 over s. So I'm going to stick with this until I simplify it. I know that x of 0 is 0, y of 0 is 0. So these terms drop out. And that leaves me with, let's see, I have some x terms that I can combine. So it'll leave me with 2s minus 2x. That's combining those two x terms. And then plus s times y equals 1 over s. I think the only thing that I might want to change there is the 2s minus 2. We can factor out a 2. So let me do that. 2 times s minus 1x plus sy equals 1 over s. So we'll do the same thing with our second equation. So I'll apply the Laplace transform to dx over dt plus dy over dt minus 5x minus 5y is equal to 2. And that will give me sx minus x of 0 plus derivative of y, sy minus y of 0 minus 5x minus 5y equals 2. And the Laplace of 1 is 1 over s. That 2 is just going to give me a 2 over s. So here again, x of 0 is 0, y of 0 is 0. So I have my x terms, and here I have a couple of y terms that I can combine. Combining my x terms, I get s minus 5 times x, and combining the y terms, I get s minus 5 times y equals 2 over s. Now, because I have that s minus 5 in common, I'm going to divide by it just to simplify the left side of the equation. And that's the same as multiplying by 1 over s minus 5. And that will give me x plus y equals 2 over s minus 5. So let me number these. I have equation 1 and equation 2. Together, these give me my system of equations. I need to decide, am I going to solve this by elimination, or am I going to solve it by substitution? My preferred method is elimination, or adding the systems together to cancel. And I see if I take equation 2 and multiply through by negative s, so I'm going to bring this over when I do that, that's going to give me negative sx and negative sy. And then on the right side, if I multiply by negative s, the s's will cancel, and I'll get negative 2 over s minus 5. So here, I can go ahead and add. And when I add, because those sy's are opposites, they will cancel out. And let's see what I'm left with. For my x terms, notice that 2 times s minus 1, that's 2s minus 2. And then I'm subtracting s. So I'm going to have 2s minus s. That's going to give me s minus 2x equals, and then on the right side, when I add, I get 1 over s minus 2 over s minus 5. And that would not be too difficult to add together. So let's go ahead and add those. We can find the common denominator between s and s minus 5, and then multiply by what we need to get that common denominator. My common denominator is s times s minus 5. And my first numerator, 1 times s minus 5, is s minus 5. And then I have minus 2 times s. So there I can simplify to get s minus 2s is negative s minus 5 over s times s minus 5. You would think maybe you could cancel out s minus 5, but if you factor that negative from the numerator, you're left with s plus 5, which does not cancel. So if I carry this s minus 2 times x down and then divide by s minus 2, that gives me my answer for x. Negative s minus 5 over s minus 5, s minus 2. So from here, we can apply the inverse transform to solve for x of t. But to apply the inverse transform, I'm going to need to do partial fraction decomposition on the right side of this equation. So I'm going to, I guess I'll do it down here. Yeah, we'll do it down here. So I'm going to take negative s minus 5 over s minus 5 times s minus 2, and that's going to be equal to some value a over s plus a value b over s minus 5 plus c over s minus 2. I'm going to multiply through by the common denominator, and that will give me negative s minus 5 is equal to a times s minus 5 times s minus 2 plus bs times s minus 2 plus cs times s minus 5. So rather than multiply all of that out, and because I have 3 distinct factors and 3 variables, I'm just going to use that shorthand method. And I'm going to start by letting s equal 5, because that will make any of these terms that contain a factor of s minus 5, it'll make those equal to 0. And then on the left side I get negative 5 minus 5, which is negative 10. On the right side, this first term and the third term drop out. And on the second term, I get 5b. That's b times 5 is 5b. And then 5 minus 2 is 3. So I get negative 10 is 15b. Divide by 15, and we have b is negative 10 over 15, or negative 2/3. So b is negative 2/3. So now let's let s equal 2. And that way, wherever I have this factor of s minus 2, those entire terms will drop out. So the a and the b will drop out, and I'll be able to solve for c. When s is 2, on the left side I get negative 2 minus 5. That's negative 7. And then for this last term, I get c times 2. That's 2c. And then 2 minus 5 is negative 3. So we get negative 6c equals negative 7. So c is going to be negative 7 over negative 6, or 7/6. That's c. There should be an equal sign here too. 7/6. So now I just need the a. And if I let s equal 0, then when s is 0, any of these terms that contain a factor of s will drop out. So the b and the c term will drop out. And on the left side of the equation, I'll have 0 minus 5. So negative 5 equals, and then I have a times 0 minus 5 is negative 5. And 0 minus 2 is negative 2. So that gives me 10a is equal to negative 5. So a is negative 5 over 10, or negative 1/2. So down here, I'm going to write x equals, and I'm just going to rewrite this using my a, b, and c. A is negative 1/2, so negative 1/2 times 1 over s. B is negative 2/3, negative 2/3 times 1 over s minus 5. C is 7/6 times 1 over s minus 2. And now when I do my last step, the inverse Laplace transform, I get my answer. X of t equals negative 1/2 minus 2/3 e to the 5t plus 7/6 e to the 2t. That's using the transforms for the inverse transforms for 1 over s, 1 over s minus 5, and 1 over s minus 2. So this is my final answer for x of t. And then I'm going to go all the way back up here to this equation. I'm going to solve it for y. Y is going to be equal to 2 over s minus 5 minus x. So I brought that x over to the right side. No, something's not right there. So that was without this 5 being canceled. Or that's not a 5. Hold on. That came from here, 2 over s. So that's an s. I know my 5s look a lot like s's, but that's an s. And this is a 5. So that should be 2 over s minus 5 minus x. And then we have x here. So y is 2 over s minus 5 minus a negative s minus 5 over s minus 5 times s minus 2. So first thing I'm going to do is change that subtraction to addition. And then the second thing I'm going to do is multiply this first fraction by s minus 2 over itself so that I have common denominators. Y is, when I distribute here, I get 2s minus 4, and combining that 2s to s, that'll give me 3s, and then negative 4 plus 5 is plus 1 over my common denominator. That's my y. From there, I want to do the inverse Laplace transform. But to do the inverse Laplace transform, I need to do partial fraction decomposition. So here, I'm doing exactly what I did down here. But I have 3s plus 1 on the left side. Let me do it this way. Over s minus 5, s minus 2 is equal to a over s plus b over s minus 5 plus c over s minus 2. And I think what I'll do is I'll expand here, and I'll compare to see which one I prefer. My common denominator is s minus 5, s minus 2. So I'm going to multiply to get, let's see if we can fit it all in here, 3s plus 1 equals a s minus 5 times s minus 2. No, I'm not going to be able to. Plus bs s minus 2 plus cs s minus 5. And I'm going to expand that on the right side. So first I'm going to multiply this s minus 5 times s minus 2 to get s squared minus 7s plus 10. And here I can just distribute by bs to get plus bs squared minus 2bs. And down here multiply by cs, and we get plus cs squared minus 5cs. So lastly, when I distribute through by the a, at the same time I'm going to combine like terms. So I have s squared terms, and so that I have s terms and then constant terms. My s squared terms are going to be a, that's as squared, plus b plus c. And then my s terms right here, I'm going to have negative 7a minus 2b, I'm going to get a little bit of space there, minus 2b minus 5c, those are s's, and then my only constant term is here, 10a, and that's equal to 3s plus 1. So I only have one constant term. Let's start with that. 1 is equal to 10a. So a is 1/10. And then my other two will give me a system. On my s terms, I have 3 is equal to negative 7a minus 2b minus 5c. A is 1/10. So that's negative 7/10 minus 2b minus 5c. If I add 7/10 to 3, 3 is 30 divided by 10. So 30/10. I'll get 37/10 equals negative 2b minus 5c. And for my s squared terms, I guess this method is longer. For my s squared terms, I have a plus b plus c equals 0, and a is 1/10. So if I bring the a over, that gives me, I'll line these up, negative 1/10 equals b plus c. So with these two equations, I could solve by substitution or elimination. I prefer elimination. And if I multiply by 2, then I'll have opposites on my b terms, and I can add these to get 37 take away 2 is 35/10 equals negative 5c plus 2c, negative 3c. So that tells me that c is negative 1/3 times 35/10. The 3 doesn't cancel, but I do have a 5 that'll cancel. This gives me c is negative 7/6. Oh, I need a new page. C is negative 7/6. And with that, I can solve for b. Let me use this. Negative 1/10 equals 2b, no, equals b plus c. C is negative 7/6. So if I bring that 7/6 over, it becomes positive, and I get b equals 7/6 minus 1/10. 1/10. My common denominator is 30. So here I'm going to multiply by 3. Here I'm going to multiply by 5. That gives me 35 take away 3 over 30, or 32/30. Oh, or 16/15. So b is 16/15. And then we're almost done. So I'm going to, wow, look how much space that took up just for the partial fraction decomposition. definitely shorter. This was definitely shorter. So I'm going to come back to this. And this is my y. So let me just copy that down. I think I copied it. And I'm going to bring it to this new page over here. Whoops. Let's try again. Uh-oh. I lost it. Try it again. Copy. Bring it to the new page. There we go. And that was y. So if I apply the inverse transform, well, wait. Let's fill in our a's. A is 1/10. So I have 1/10 times 1 over s. B is 16 over 15. And that's times 1 over s minus 5. And C is negative 7/6. That's a minus 7/6 times 1 over s minus 2. So now my inverse transform is going to give me y of t equals 1/10. Inverse transform of 1 over s is 1. And then plus 16/15. The inverse transform of 1 over s minus 5 is e to the 5t minus 7/6 e to the 2t, the inverse transform of 1 over s minus 2. And that should be our y of t. That one took about a half an hour. Wow. And that's the last problem.